Students, today we are going to start the topic part 2 polynomials. First class we have completed polynomial 2.1, that one you have already understood. The second part 2.2, that is topic is zeros of the polynomial. What is the zeros of the polynomial? The zeros of the polynomial is defined as any real value of x for which the polynomial became 0. That means at which value the polynomial became 0, that is the zeros of the polynomial. See one example, one linear polynomial you take, linear polynomial. See ax plus b, then this is p of x, means x is the variable and a and b are constant. So if I put you find out the value that this one is x, ax plus b equal to 0, then ax equal to minus b and x equal to minus b by a. So now p, in p of x I put this value. If I put this value here, minus b by a, so a into minus b by a plus b. Now you see a cancel. Here you get minus b plus b is 0. That means this polynomial at this value became 0. You can take any number also, like you see 3x plus 5. Let this one is p of x. So now you find out the value here. What is the value coming? 3x plus 5 equal to 0. Let x 3x equal to minus 5, x equal to minus 5 by 3. Okay, minus 5 by 3. Now you put this value in this equation, p of x, we put minus 5 by 3. What is coming? Equal to 3 into minus 5 by 3 plus 5. Cancel, minus 5 plus 5 equal to 0. Okay, so now you understood the linear polynomial. In case of linear polynomial, you get only one root. This particular root you will get. But in case of quadratic polynomial, you get two roots. See, this is a linear polynomial in standard form. Then you see linear polynomial have only one zero or one root. Root and zero same thing. But you can say zero or roots. So in case of quadratic polynomial, we have two zeros. Let this is a quadratic polynomial ax square plus bx plus c, where here you can mention that a, b, c are real number and a is not equal to 0. This should be mentioned. So a, b, c are real number and a is not equal to 0. If a became 0, this part became 0. So it became a linear polynomial. So we have to write that a is not equal to 0. So ax square plus bx plus c equal to two roots. So one root is alpha and the root is beta. So it is in this form. If it is coming in this form, then alpha and beta are the roots of the polynomial. We will take one example and explain this.
Action.
Okay. See here, x square plus ax square plus bx plus c in form of x minus alpha, x minus beta. Then alpha, beta are the zeros of the polynomial. Okay, so ax square plus bx plus c is the standard form of this one. Take one example. Let's see, this one is one example. X square minus 5x minus 6. This is a quadratic polynomial. Middle term factorization you know in standard 8 classes. Just you see, you have to factorize this minus 5x in such a way, break in two parts. When you add, it is coming minus 5x. When you multiply, it should come minus 6x square. So I make it minus 6x plus x. See, x square minus 6x plus x minus 6. So x whole into taken common, remainder x minus 6 plus 1 taken common, x minus 6. So x minus 6 whole into x plus 1. So this one is now in the form of this part, you see. X minus alpha, x minus beta. So this one minus means we take this one is this one and this one is this. Okay. So now if this total polynomial became 0, that means this one is 0 or this one is 0. Out of this part, one part is 0. See which part is 0. If x minus 6 equal to 0, then x equal to, taken that side, plus 6. So this one is the alpha. This value you can say this is alpha, alpha. And if take the other side, x plus 1 equal to 0, that means x equal to minus 1. So here minus 1 is beta, plus 6 is alpha. So alpha and beta here, two zeros of the polynomial. One is coming 6, another is coming 1, minus 1. If you put this value as per the rules, if it is coming, you see 6 or minus 1, you put in the p of x value of x. If the value of x is 6 or minus 1, then the polynomial became 0. Now you see, put the value here, p of x, p of 6. X square, 6 square, 5x, 5 into 6 minus 6. So 6 square 36, 5 into 6 30 minus 6. So 36 minus 36 equal to 0. So now you see this one is one of the zeros of the polynomial. Another one you test. P of minus 1 equal to minus 1 square minus 5 whole into minus 1 minus 6. See, minus 1 square plus 1, why? Minus into minus plus. So minus 1 into minus 1 equal to plus 1. Minus into minus plus 5. So this is minus 6. So add this is 6 minus 6 equal to 0. That means minus 1 is also the zeros of this polynomial. So this polynomial is a quadratic polynomial. This polynomial is a quadratic polynomial. In a quadratic polynomial having a degree 2, having two roots. One is alpha, another is beta. Here alpha is coming 6 and beta is coming minus. We also verify this. Like some questions are there in 2.2. Just you verify the zeros and find the zeros of the polynomial. In this exercise, complete this. This is the homework exercise 2.2. Any doubt you can ask me, you can call me, and you in YouTube you are seeing my video, like, share and also comment for my video. Thank you.